All right, so let's talk about the calculus concept of finding tangent lines. So, first of all, what is a tangent line? A tangent line is a line that touches a curve at exactly one point. So look at this graph that I drew up here. I have a y equals x squared curve, and you see there's a line that's touching it. And so it's touching it at exactly one point. And so what happens is that tangent line at the point that it's touching the graph, it has the exact direction of the curve at that one point. That place where it just touches it, that's the direction of the y equals x squared curve. And so that literally the tangent line is telling you the slope essentially of y equals x squared in this case at that exact point. All right. So that's the value of a tangent line to let you know what the slope of a curve is at a particular point. This is a very foundational kind of thing when it comes to everything else you learn in calculus, like all the derivative stuff. All right, now, so it's useful sometimes to find the equation of the tangent line. But to find the equation of any line, remember this stuff here. So remember back in Algebra 1 when you learned about this stuff, y equals mx. Let me make that look a little better. Mx plus b. This is your slope right here. This was called your y-intercept. Okay, so this formula is called the slope-intercept formula. And all you needed to know to find the equation for a line using slope-intercept was the slope and the y-intercept. Keep in mind that the slope is kind of like how essentially how a graph kind of leans, how it kind of goes up or down, like its pitch, if you will. The y-intercept is where the line or whatever it is intercepts the y-axis. Okay. Now, so all you would need to find was m and b, and then you would have essentially your equation for a line. So, but the thing is, if you recall, if you want to find the slope of a particular line, one point is not going to cut it. You need at least 2 points. All right. So check this out here. We don't have 2 points on this particular tangent line. We have 1 point. However, what you can do is you can kind of approximate, so to speak, by choosing a nearby point on the curve, well, in this case, the x squared curve, a point that's very close by. So here, let me label this here. I forgot to label. So say this is 1 and 1. Say that, okay, so if this is 2, say that and this isn't the best drawing. Yeah, it just isn't the best, so you're going to kind of have to like just bear with me and use your imagination. So say, for example, that we were to choose a point nearby on the curve to kind of like approximate where the tangent line is. This point, so check this out. So if this point right here is 1, 1, we're going to call this point right here, the x coordinate is going to be, now we're going to ignore this for a second here, 1.5, because matter of fact, let me erase that for a second, because that, just kind of imagine we just chose some sort of point we don't even really know yet, but it's somewhere a little bit higher up. We're going to call the x coordinate for that, we're just going to call it x. Keep in mind that, let me do this here. Keep in mind that the equation for our curve is y equals x squared. So the x coordinate is just going to be x. The y coordinate is going to be x squared. right? Because y is equal to x squared. Okay. Now, so that said, remembering that to find the slope, m equals y2 minus y1 over x2 minus x1. So choosing this point that's close to the original tangent line point, just a little ways up or whatever. Now we have a second set of second point, so to speak, to work with, at least an approximate, a point to approximate with. So that's going to be, if you were to find the slope here, now n would be equal to y2, which is going to be x squared minus y1. This is supposed to be a 1 right here, over x2 minus x1. Okay. So now we are able to kind of find our slope. Now, say for example, now I'm going to add this number in. For example, and let me get my calculator here in case I need it. But so now, say for example, that the point that we chose was going to be x is equal to 1.5. That would literally be, so x squared, that'd be 1.5 squared minus 1 over 1.5 minus 1, which is going to be, so give me a second here so I can zoom in with my notes, because I do take notes before I do these videos for the most part. So 1.5 squared, let's do that. Oops. Okay. Well, I'm just going to rely on my notes because my calculator is pretty much dead, unfortunately. So 1.5 squared is going to be 2.25 minus 1 over 1.5 minus 1, which is going to be 1.25 divided by 0.5. So that is a slope of 2.1. Okay. Now, say, for example, we chose a point that's even closer. Let's say we kind of got right up close to here. And that's x is equal to 1.1. 1.1. So that slope would be, remember, x squared minus 1 over x minus 1. So that'd be 1.1 squared minus 1 over 1.1 minus 1, which is going to be 1.21 minus 1 over, I'll go ahead and do that subtraction, 0.1. So that's going to be 0.21 over 0.1, which is just going to be 2. Actually, I'm sorry, I wrote this down wrong. This right here was 2.5. This is 2.1. Now, if you get a few more points closer and closer and closer to your tangent point, without being equal to the tangent point, of course, then what you'll notice is as you get closer and closer to x, the tangent point, then this gets closer and closer. The slope gets closer and closer to 2. So essentially, the other thing I want to say is when you have 2 points here, the line that is created from the 2 points, that's your secant line. So a tangent line has 1 point. A secant line is made by the 2 points. So essentially what you're doing is when you're making these approximations to find the slope, you're making a lot of little secant lines to kind of like approximate that slope, basically. So what happens is the slope of the tangent line is going to be equal to the limit of the slopes of the secant line. So again, keep in mind, you have all these lines that are being created when from this point to this point. Then if you choose another point here, there's a line from here to here. You choose another point in there, just imagine a line there. So you have all these many points that you're taking. So again, let me write that down, what I said. The limit of the slopes of the secant lines is equal to the slope of the tangent line. That's like the main idea right there. And to write that out actually mathematically, it would look like this. So so say for example, this tangent line was labeled P. I mean, this tangent point 1, 1 is P and this is Q. The way you would write this out is the limit as Q approaches P. So in other words, as this point here, that second point you choose, approaches that tangent point, the limit of that for the slope is going to be equal to your tangent slope, the slope of the tangent line. In this case, for this particular y equals x squared, the limit as x approaches 1. So in other words, we know that our tangent line touches at 1, 1. So the limit as the x value chosen approaches that tangent point of 1 for, of course, the slope, which is x squared minus 1 over x minus 1 is equal to 2, as we just talked about. Now, keep in mind, if you look at that, you can, with x squared minus 1 here, you know, that's a difference of squares, which is x plus 1, x minus 1. So the x minus 1 up top and the x minus 1 at the bottom cancel. And then you can plug in that 1 into the x plus 1, and that'll give you 2. So you see, this shows how to find your slope. It's the limit of the slopes of the secant lines. Okay, hopefully that's understandable. Now, that said, now I'm gonna I gotta clear out some space here. So if you need that graph, just rewind your video. So now we know, based on the limit that we use, that our slope of our tangent line is 2. Now remember, we want to find the equation for that tangent line. So now we have the slope. Now we need to find the y-intercept. Remember, to find the y-intercept, you need the slope and you need at least 1 point on the line. We have the slope and then we have that 1 point on the line, the tangent point. So that's going to be, remember the tangent point was 1, 1. So let's plug in 1 for x and 1 for y. So y equals mx plus b. So that's 1 equals, the slope is 2 times the other one plus b. 1 equals 2 plus b. I need to stop writing so quickly. Subtract 2 from both sides. So b is equal to -1. Now you have your b, you have your m, and now you have the general equation for your line, the slope-intercept form of your line. Y equals 2x minus 1. The equation for your tangent line. So keep in mind that the limit of the slopes of the secant lines, when you're choosing that second point on the curve that's getting closer, ever closer to the tangent point, the limit as those points approach the tangent point is equal to the slope of your tangent line. You can use that slope to get your y-intercept and then ultimately to get the equation for your tangent line, okay? All right, hopefully I was helpful. Make sure you like this video, share it, subscribe to this YouTube channel. If you need tutoring, you see the information at the bottom. If you need help with the SAT, ACT math, you see the link at the bottom. And yeah, that's pretty much it. Y'all have a great day.